Hello, diploma students. Okay, we are going to start with calculus today. All right, to start with calculus, we are going to look at the rule of differentiation. There's a few names given for differentiation. It's either differentiation or derivatives, and they are written like this. If an equation is written as fx, the differentiated equation will be written as f dash of x. Or another case, if a equation is written as d of x or y is equals to, it can be also written as y is equals to something, and then when it's differentiated it can be written as dy over dx. Or if it is just a y, the differentiated equation can be written as y dash. Okay, we are going to look at a few rules and a lot of examples on calculus. Okay, rule number 1. So if your equation is given in this form, x to the power of n, to differentiate, the rule is we'll multiply the power in the front, n minus 1 from the power. So f dash of x, the n will go and multiply in the front, n will do minus 1 from the power. Right? Rule number 2. Excuse me. If it is f of x is a k means if k is any number, for example, k is 3, k is 5, or k is 7, or k is 2. To differentiate, if we differentiate a number, it will be 0. Rule number 3. So, if in this case, another case like this, if it is a number instead of 8, for example, 3, right? So, to differentiate, what I will do, multiply the power in the front, and then minus 1 from the power. So rule of differentiation is you multiply the power in the front and minus 1 from the power. If the equation is given as an expression something plus something, so we will differentiate them separately. We'll differentiate this and then we'll differentiate that. Okay, all right, we are going to look at few examples, and these examples will help you work out the answers. If I have the question f of x is equals to 3x to the power of 4 minus 7x plus 2. So let's differentiate. The 4 will come and multiply in the front. 4 3 is a 12x cubed. 7x, the 7x will be differentiated to 7. This is important. 7x, you will just remove one of the x's, so 7x will be differentiated to 7. Example number 2. So if I have 5x cubed, so the 3 will go and multiply to the front. 5 3 is a 15, and I have subtracted 1 from the power, which is x squared. So my answer is 15x squared. Okay, we're going to look at another example. Example number 3. So y is equals to 2x squared plus 3x minus 5. Again we are differentiating. The 2 will go and multiply in the front. 2 2s are 4 and 2 minus 1. The power here is 1, but we normally don't write 1. We understand it, the power is 1. And 3x will be differentiated to 3. Right? Number 4. Y is equals to x cubed plus 2x plus 1. Again, the power will go and multiply in the front, 3x squared, and 2x will be differentiated to 2. Right? Next one. Okay, this is a little different case than the ones that we have discussed above. We can see our variable is in the power. Now, one common rule, even when you are solving the equations, if your variable was in the denominator, you cannot solve it. Likewise, in this case, if your variable is in the denominator, we cannot differentiate it. The rule is you have to take it to the numerator. So we will be using our laws of indices. The laws of indices, when I want to take this to the numerator, it will be 2x to the power of negative 1. So if I have the x in the denominator, it can go on the top, but power will be negative 1. Now I've written like this. Everything is in the numerator. And then now I am going to differentiate it. Again, the power will go and multiply in the front. 2 times negative 1 is negative 2, and I'll minus 1 from the power. So negative 1 minus 1, I'll have a negative 2. And this x will be differentiated to 1. You can see that. Right? Okay. Let's go on to another example. So here I have a square root. F of x is square root of x plus 1 over x squared. Make sure we have to change everything in terms of power. This will be changed in terms of power, and when I have a x in the denominator, that will be taken to the numerator. X to the power of half plus x to the power of negative 2. Right? Power will go and multiply in the front and minus 1 from the power. So half will go and multiply in the front, will become half x, and half minus 1 will be negative half. Right? Half minus 1 will be negative half. Plus 2, negative 2. This negative 2 will come and multiply in the front. Negative 2 will be multiplied in the front, and then I'll minus 1. Negative 2 minus 1 will be negative 3. So my differentiated equation is looking like that. Okay, it's my answer there. Right? Okay, another one. When I have a fraction in the front, again the same rule. The power will go and multiply in the front and minus 1 from the power. So 4 will multiply there. There you go. And then I'll minus 1 from the power. 4 minus 1 is 3. My differentiated equation is that one. Okay. Another example. Example number 9. Now y is equals to 1 over root x. So square root x means x to the power of half. Right? Now I cannot differentiate it since it's in the denominator. I will have to take it to the numerator. Okay, and then when I'll differentiate, the power will go and multiply in the front times x to the power of negative half minus 1 is negative 3 over 2. Or it's okay if you want to leave your answer as decimal, but I would always suggest to leave it as a fraction. Okay, another one. Cube root of x. Now cube root of x, if I want to rewrite, it will be x to the power of 1/3. And then again 1/3 will be multiplied in the front, x to the power of negative. So 1/3 here, 1/3 minus 1 will be negative 2/3. 1/3 x to the power of negative 2/3. Okay, example 11. Same here. My variable is in the denominator. So I'll have to first take it to the numerator. Then I can differentiate. So negative 4 times 5 is negative 20. X to the power of minus 4 minus 1 is negative 5. Right? Okay, this is a little different one. Alright, can you see all of this expression has the denominator of x. Now you cannot differentiate this one straight away. You have to rewrite. We have to separate all that. Okay, so if I want to separate, that means this x is given the denominator to all the three elements. There you go, there you go, there you go. Right? And then I have to simplify. I will always differentiate the most simplified expression. So I've just cancelled one x's from here, a set of x's from here, and once I cancel, I'm ending up like this. So after that, when I want to differentiate, then let's differentiate the way we know. The 2x will be differentiated to 2, 3 will be differentiated to 0. Remember, one of our rule was the number will be differentiated to 0. And this one, negative 1 will go and multiply in the front. So I'll have a negative 1 here, but we normally do not write that, and we understand it's a 1. X to the power of, so minus 1 will be minus 2. So f dash of x will be, once I simplify, 2 minus x to the power of negative 2. Okay, our last example. Y is equals to x plus 2 everything squared. Okay, can you see my entire expression is x squared? And in this case again, I cannot differentiate. I'll have to separate them or expand them. So once I expand, my expanded equation is this. Now I can differentiate. The power will go multiply in the front and minus 1 from the power. There you go. 4x will be differentiated to 4. Thank you.